Good morning, parents, teachers, and students. Welcome back to Valenzuela Facebook Live in Mathematics 9. Are you excited for our fun learning session? Come on, let us learn and have some fun and allow me to guide you in learning the different concepts and skills in Mathematics 9. Before we begin, make sure you have your module with you, your notebook, and a pen for taking down notes. You may also use the chat box to key in your answers to the questions that I will be giving throughout the discussion. Are you ready? Great! Let's start. Today, we will be discussing direct and inverse variations. At the end of the discussion, you must be able to illustrate situations that involve direct and inverse variations. Translate into variation statement a relationship between two quantities given by a table of values, a mathematical equation, a graph, and vice versa. And solve problems involving direct and inverse variations. Let's begin with the first activity entitled Complete Me. Complete each statement which shows the relationship of two quantities by filling in the blank with the word increases or decreases. Statement number 1. As the weight in kilogram increases, the total cost of fish blank. Is it increases or decreases? You have 10 seconds to complete the relationship. Go! Time is up. The answer is increases. As the weight in kilogram increases, the total cost of fish increases. Good job! Let's proceed to second statement. As the number of days he worked increases, the salary he gets blank. Is it increases or decreases? You have 10 seconds to complete the relationship. Go! Time is up. The answer is increases. Great! As the number of days he worked increases, the salary he gets increases. Third statement. As the speed of the car decreases, the distance covered in fixed time blank. Is it increases or decreases? You have 10 seconds to complete the relationship. Go! Time is up. The answer is decreases. Excellent. As the speed of the car decreases, the distance covered in fixed time decreases. Fourth statement. As the number of men working increases, the amount of time to finish the job blank. Is it increases or decreases? You have 10 seconds to complete the relationship. Go! Time is up. The answer is decreases. Perfect. As the number of men working increases, the amount of time to finish the job decreases. Last statement. As the speed of the car decreases, the time it takes to arrive to its destination blank. Is it increases or decreases? You have 10 seconds to complete the relationship. Go! Time is up. The answer is increases. Awesome. As the speed of the car decreases, the time it takes to arrive to its destination increases. Thank you for your participation, students. These statements show situations that illustrate direct and inverse variation. The first three statements illustrate direct variation wherein if one quantity increases, then the other quantity also increases. Likewise, if one quantity decreases, then the other quantity also decreases. While the last two statements illustrate inverse variation, wherein if one quantity increases, then the other quantity decreases, and vice versa. Let's have a deeper discussion on these two kinds of variation. Let's start with the direct variation. The statement y varies directly as x or y is directly proportional to x can be written in the form y is equal to kx or k is equal to y over x, where k is equal to variation. The variables x and y are the two quantities. Now, using the concept of direct variation presented, let us translate the following variation statements into mathematical equations. Number 1, the cost C of the fish varies directly to its weight W in kilogram. This statement can be translated into mathematical equation as C is equal to KW or K is equal to C over W, where C is the cost of the fish, K is the constant of variation, and W is the weight in kilogram. Next, a worker's salary S varies directly as the number of hours each worked. So, what is the mathematical equation of this statement? Very good. This statement can be translated into mathematical equation as S is equal to KH or K is equal to S over H, where S is the worker's salary, K is the constant of variation, and H is the number of hours worked. Furthermore, we can also observe direct variation using table of values and graph. Look at this example. Avery plans to buy rice out of her own savings. She wants to help her mother, whose work has been affected of the community quarantine implemented by the government due to pandemic. She decided to buy rice that cost 40 pesos a kilo. What do you think are the two quantities involved in the given situation? Very good. The quantities are the number of kilos and the cost of rice. Let x be the number of kilos and y be the cost of rice. Let us complete the table below showing the relationship between the number of kilos x of rice bought and the total cost of rice y. How much is the cost of 3 kilograms of rice? Correct. It's 120 pesos. How about the cost of 5 kilograms of rice? Excellent. It's 200 pesos. As you noticed, as the number of kilos X increases, the total cost of rice also increases. It is one condition that the given table of values represent direct variation because as one quantity increases, the other quantity also increases. Aside from this condition, you must also check if there is a constant of variation. The statement, the cost of rice Y varies directly as the number of kilos X, can be translated as Y is equal to Kx or K is equal to Y over X. We could find the constant of variation or K by dividing the value of Y by X. 40 divided by 1 is 40. 80 divided by 2 is 40. 120 divided by 3 is 40. 160 divided by 4 is 40. And 200 divided by 5 is 40. The quotient of y divided by x is constant, which is 40. Therefore, the constant of variation is 40. Substitute the value of k. The equation that represents the table of values is y is equal to 40x. Now, let's check the kind of graph that this direct variation has. Out of this table of values, we have 5 ordered pairs. 1, 40, 2, 80, 3, 120, 4, 160, and 5, 200. Plot these points on a Cartesian plane. Here is the Cartesian plane. The interval in x-axis is 1 and the interval in y-axis is 40. We have 1, 40, 2, 80, 3, 120, followed by 4, 160, and lastly, 5, 200. Next, connect the points. What kind of line do you see? Exactly! We have a straight line like the graph of a linear equation, and it rises from left to right. So, this means that the graph of our given table of values is increasing. In the given table of values and graph, x and y can't be negative because of the presented situation earlier. Now, let me present another example of a table of values and a graph that represents direct variation. Here is the table of values. What is the equation that represents the given table of values? Very good. It's y is equal to 5x. Out of this table of values, we have 5 ordered pairs. Negative 3, negative 15, negative 2, negative 10, negative 1, negative 5, 1, 5, and 2, 10. Plot these points on a Cartesian plane. Here is the Cartesian plane. The interval in x-axis is 1 and the interval in y-axis is 5. We have negative 3, negative 15, then negative 2, negative 10, next, negative 1, negative 5, followed by 1, 5, lastly, 2, 10. Next, connect the points. The graph rises from left to right. This means that the graph of our given table of values or the equation y equals 5x is increasing. Always remember that the graph of the direct variation equation is a straight line and it passes through the origin. But we will not be using the coordinates 0, 0 or the origin in finding the constant of variation. Remember that 0 divided by 0 is undefined. At this point, let us test your understanding about the direct variation by having Activity 2 entitled, Am I direct or not? Determine whether the given equation, table of values, or graph illustrates direct variation. Number 1, y is equal to 12x. Comment like emoji if it is direct variation and heart emoji if it is not. You have 10 seconds to key in your answer. Go! Time is up. If you answered like emoji, then you're right. Amazing! How about this table of values? Comment like emoji if it is direct variation and heart emoji if it is not. You have 10 seconds to key in your answer. Go! Remember that as the value of x increases, the value of y must also increase, and the quotient of y divided by x must be constant. Time's up! If you answered heart emoji, then you're right. Fantastic! In the given table of values, as the value of x increases, the value of y decreases. Therefore, it is not a direct variation, and the quotient of y divided by x is not constant. Here is the given in number 3. Comment like emoji if it is direct variation and heart emoji if it is not. You have 10 seconds to key in your answer. Go! Check if as the value of x increases, the value of y also increases. And when you divide y by x, the answer is constant. Time's up! If you answered like emoji, then you're right. Awesome! As the value of x increases, the value of y also increases, and the quotient of y divided by x is constant, which is 5. For the last given, it is a graph. Comment like emoji if it is direct variation, and heart emoji if it is not. You have 10 seconds to key in your answer. Go! Recall that the graph of a direct variation is a straight line and passes through the origin. Time's up! If you answered like emoji, then you're right. Excellent! The graph rises from left to right, and it is a straight line. The constant of variation is 60. After dealing with translating the statements into mathematical equations, graphs, and table of values, let us now solve problems involving direct variation. Here are the steps in solving problems involving variation. Step 1. Write the variation statement into a mathematical equation. Step 2. Solve for the constant of variation. Step 3. Substitute the value of k in the mathematical equation. And step 4. Solve for the unknown variable. Let's have problem number 1. If g varies directly as m and g is equal to 24 when m is equal to 8, find g when m is equal to 6. First step, write the variation statement into a mathematical equation. What is the mathematical equation of the given statement? Awesome! The mathematical equation of the given statement is g is equal to km or k is equal to g over m. Step 2. Solve for the constant of variation which is k. To solve, We will use the given g is equal to 24 and m is equal to 8. Then substitute it to the second mathematical equation. By substitution, k is equal to 24 over 8. Simplify, 24 divided by 8 is 3. Thus, the constant of variation is 3. Third step, rewrite the mathematical equation by substituting the value of k we got in step 2, which is 3, with the first mathematical equation we have in step 1, which is g is equal to km. So we have g is equal to 3m. Fourth step, solve for the unknown variable in the problem, which is g. To do this, substitute m is equal to 6 to g is equal to 3m. We have g is equal to 3 times 6. Simplify, 3 times 6 is 18. Therefore, the value of g is 18. Let's have another example. Castiel is riding his car leaving Valenzuela City to visit his parents in Bulacan. The distance d traveled varies directly to the number of liters L of gasoline consumed to travel. His car consumes 8 liters of gasoline to travel 80 kilometers. How many liters of gasoline will the car consume to travel 120 kilometers? In this problem, we have liters of gasoline and distance traveled as the two quantities. We need to write the variation statement into a mathematical equation. What is the mathematical equation that represents the relationship of these quantities? Very good. It's D is equal to KL, or K is equal to D over L. Next step, solve for the constant of variation. In the problem, it states that his car consumes 8 liters of gasoline to travel 80 kilometers. Therefore, D is equal to 80 and L is equal to 8. Let us use this given to solve for K. By substitution, K is equal to 80 over 8. Simplify, 80 divided by 8 is 10. The constant of variation is 10. Let's now substitute the value of k in the equation. D is equal to KL. We have D is equal to 10L. We will be using this equation to get the liters of gasoline that a car will consume to travel 120 kilometers. By substitution, if D is equal to 120, then 120 is equal to 10L. Divide both sides by 10. 120 divided by 10 is 12, and 10L divided by 10 is L. Therefore, the liters of gasoline that a car consumes to travel 120 kilometers is 12 liters. I hope you got the same answer. Can you still follow? Click the care reaction if yes. Great. Let's now proceed to inverse variation. While direct variation describes a linear relationship between two variables, inverse variation describes another kind of relationship such that for any quantities x and y, an increase in x causes a decrease in y, or vice versa. We can say that y varies inversely as x, or y is inversely proportional to x, which can be written in the form y is equal to k over x, or k is equal to yx, where k is the constant of variation. To apply these concepts on inverse variation, let's translate the statements into mathematical equations. Number 1, the speed s of a vehicle is inversely proportional to the time t it takes to travel a fixed distance. This statement can be translated into mathematical equation as S is equal to K over T, or K is equal to ST, where K is the constant of variation, S is the speed of a vehicle, and T is time. Another, to balance a seesaw, the weight W is inversely proportional to the distance D from the fulcrum. This statement can be translated into mathematical equation as W is equal to K over D, or K is equal to WD, where K is the constant of variation, W is the weight, and D is the distance. Next, let's have this situation. Annalise wants to have an extension of her house. She understands that the number of days required to finish the work depends on the number of workers. The following are some possible number of days and number of workers. What did you notice about the values of X or the number of workers? Correct. From 2 to 24, it is increasing. How about the values of Y or the number of days? Exactly. From 24 to 2, it is decreasing. As one quantity increases, the other quantity decreases. This is an example of inverse variation. Aside from this condition, there should be a constant of variation. We could determine the constant of variation by multiplying X and Y. Take note that the number of days to finish the job, Y, varies inversely as the number of workers, X. The equation is Y is equal to K over X, or K is equal to YX. 24 times 2 is 48. 12 times 4 is 48. 8 times 6 is 48. 6 times 8 is 48. And 2 times 24 is 48. The product is constant. Therefore, the constant of variation is 48. And the equation that represents the table of values is Y is equal to 48 over X. Out of this table of values, we have 5 ordered pairs. 2, 24, 4, 12, 6, 8, 8, 6, and 24, 2. Plot the points on a Cartesian plane. We have 2, 24, 4, 12, 6, 8, 8, 6, and 24, 2. Then, connect the points. This is now the kind of graph that an inverse variation has. Remember, the graph of an inverse variation is a hyperbola. It never passes through the origin. Also, it never crosses the x or y axis. The x and y axes are called the asymptotes of the hyperbola. In the given graph, it is just half of the hyperbola because the values of x and y can't be negative based on the presented problem earlier. Now, let's have another table of values that represents inverse variation. Again, In an inverse variation, the product of y and x must be constant. In the given table of values, what is the value of the constant of variation? Exactly! It is 24. Therefore, the equation that represents the table of values is y is equal to 24 over x. Out of this table of values, we have 5 ordered pairs. Negative 6, negative 4, negative 2, negative 12, 3, 8, 4, 6, and 8, 3. Plot the points on the Cartesian plane. We have negative 6, negative 4, negative 2, negative 12, followed by 3, 8, next 4, 6, and lastly 8, 3. Connect the points on quadrant 1 and connect the points on quadrant 3. Here is the graph of the given table of values and the equation y is equal to 24 over x. Again, the graph of an inverse variation is called hyperbola. Let us test your understanding about translating statements into a mathematical equation, graph, and table of values of an inverse variation by having Activity 3 entitled, This is my equation. Given that y varies inversely as x, find the constant of variation and the equation of the relations presented below. The first given is a table of values. Find the constant of variation and the equation of the relation. You have 10 seconds to key in your answer. Go! Remember that the product of x and y is the constant of variation. Time's up! If you answered k is equal to 60 and y is equal to 60 over x, then you're right! Amazing! The second given is another table of values. You have 10 seconds to key in your answer. Go! Multiply x and y to get the value of the constant of variation. Time's up! If you answered k is equal to 2 and y is equal to 2 over x, then you're right! Awesome! The last given is a graph. You have 10 seconds to key in your answer. Go! Find the coordinates of the points, then multiply x and y. Time's up! If you answered k is equal to 8 and y is equal to 8 over x, then you're right! Excellent! After translating statements into mathematical equations, graphs, and table of values, let's now solve problems involving inverse variation. And again, we will be using these steps to solve problems involving inverse variation. Problem number 1. If y varies inversely as x and y is equal to 12 when x is equal to 2, find y when x is equal to 8. First, write the variation statement into mathematical equations. So we have y is equal to k over x, or k is equal to yx. Next, solve for the constant of variation. Let's use the equation k is equal to yx to solve for the constant of variation. The given are y is equal to 12, and x is equal to 2. By substitution, k is equal to 12 times 2. Simplify. 12 times 2 is 24. Hence, the constant of variation is 24. Then, substitute k equals 24 to y is equal to k over x. That is, y is equal to 24 over x. Afterwards, solve for the unknown variable. We use the remaining given, which is x is equal to 8, to the new mathematical equation y is equal to 24 over x. By substitution, y is equal to 24 over 8. Simplify. 24 divided by 8 is 3. Therefore, the value of y is 3. Did you get the same answer? Great! Before we proceed to the last example, let me give a trivia. Did you know that the Philippines is home to more than 7,000 stunning islands and even more beautiful beaches, with some of it considered as the best in the world? But there's more to this Southeast Asian country underneath its paradise-like islands and beaches. Diving in the Philippines will treat you to incredible sights and experiences like swimming with treasure sharks in Cebu, exploring World War II shipwrecks in Palawan, and discovering a UNESCO World Heritage Site in Puerto Princesa. These are just some of the best diving sites here in the Philippines. But did you ever wonder how scuba divers breathe underwater? We know that nose breathing is best for our lung health, but with a scuba equipment, a diver must breathe out of their mouth with the help of a regulator that is connected to an oxygen tank. And the last example of word problem involving inverse variation is related to scuba diving. Last problem. Boyle's law states that if the temperature of a gas stays constant, then the pressure P varies inversely to the volume V of the gas. Asher, a scuba diver, has a tank that holds 6 liters of air under a pressure of 220 pounds per square inch or PSI. If the pressure increases to 330 pounds per square inch, how much air can Asher's tank hold? In this case, we have pressure and volume as the two quantities. What is the equation of the variation statement? Very good. It's P is equal to K over V, or K is equal to PV. Next, solve for the constant of variation. We can use K is equal to PV to solve for K. The given are V is equal to 6 and P is equal to 220. By substitution, K is equal to 220 times 6. Simplify. 220 times 6 is 1,320. Hence, the constant of variation is 1,320. Then, substitute K equals 1,320 to P is equal to K over V. Then, P is equal to 1,320 over V. Afterwards, solve for the unknown variable. By substitution, substitute P is equal to 330. 330 is equal to 1,320 over V. Multiply both sides by V, Simplify. The equation will be 330V is equal to 1,320. Divide both sides by 330. V is equal to 4. Therefore, Asher's tank can hold 4 liters of air. Wow! It has been a long discussion today, but it is an amazing learning session. I hope you learned something essential today. To sum it up, in direct variation, the statement y varies directly as x or y is directly proportional to x can be written in the form y is equal to kx or k is equal to y over x, where k is the constant of variation. In inverse variation, the statement y varies inversely as x or y is inversely proportional to x can be written in the form y is equal to k over x or k is equal to yx, where k is the constant of variation. You could use these steps to solve problems involving direct and inverse variations. 1. Write the variation statement into a mathematical equation. 2. Solve for the constant of variation. 3. Substitute the value of k in the mathematical equation. And 4. Solve for the unknown variable. Let's now proceed to our question and answer. A question from one of our viewers. Is there any alternative method in solving direct variation, ma'am? Yes, there is. You can use the concept of proportion to solve problems involving direct variation. For other questions, you may ask your class discussion teacher and he or she will discuss it in your follow-up discussion. Moreover, I want you to answer test 2. Keep trying on page 5 of your module to be checked during your follow-up class discussion. Thank you so much for watching and participating. Stay safe, healthy, and motivated. Have a great day, everyone. Bye!